Hello students, in this video lecture we will see the next example of finding the resultant of space forces. We have to find the resultant and the couple moment about the origin for the system of forces shown in the figure. We have four forces basically: F1 originating from D and going towards B, F2 originating from origin going towards point G, F3 starting from point F going towards D and magnitude is 30, whereas F4 originating from A going towards F. The distances of the dimension of this block is given to me as 4 meters along OA, that is over here. OC is given to me as 5 meters and OE is given to me as 3 meters along the z-axis. So using this dimensions, I need to find out the coordinates of the various points. If I take point A, since point A is lying on the x-axis, y coordinate and z coordinate will be 0. So the coordinate of point A will be 4, 0, 0. Similarly, I can find coordinate of point B. Now point B is lying in the xy plane, so z coordinate will be 0 in that case. My x distance happens to be 4 meters and the y distance happens to be 5. Z will be 0. I haven't found the coordinate of C. The reason for that is there is no force at this point, so there is no need to find the coordinates. If I find the coordinate of D, so in that case point D lies in the YZ plane. So x coordinate will be 0 in that case. Y distance I know is 5 meters and the Z distance is 3 meters. Similarly, for point F, F point lies in the XZ plane. So Y coordinate will be 0, X is 4, Z is 3. Now, what I need to do is I need to find the resultant of these four forces. And we know that resultant is nothing but the summation of all the force vectors. So the first thing that I'll do is try to find out the resultant of these four forces. Now force vector for force 1, that is this force, will be the magnitude and the dot product of the unit vector along dB. So for that I need to find out the force vector and the unit vector. So force 1 dot product unit vector along BD. Actually it should be dB since the force is originating from point D. So I'll write it as F1 unit vector dB plus force 2, the magnitude, dot product unit vector for force 2, that is from O to G, so unit vector along OG plus F3 magnitude dot product with the unit vector as FD plus F4 along AF. Now I know the magnitudes, I know the coordinates, so I can easily find the force vectors. So the unit vector along DB will be the coordinate B minus the coordinate of D. So that will be the next force vector, that is F2, will be for this, the force vector is originating from O and it is going to G. So I need to find the coordinates of G, and that will be, I'll write it over here. Along X it is 4, Y 5 and 3. So it will be 0 minus 4, 0 minus 5 and 0 minus 3. Then the force vector for force 3 will be the magnitude of 30, and since the force F3 is passing through points F and D, it will be D minus F. So 0 minus 4, 5 minus 0 and 3 minus 0. And the next force vector 4 will be the magnitude and dot product of the unit vector along AF. So that will be F minus A I can simplify the force vectors to find out the force vector over here. It will be 20 by 5, so that will be 4 into 4i, that should give me 16i, plus this will be 20 by 5, that is 4 into 0 is 0, and this will be minus 3, so this will be minus 12k, plus over here this value will be 7.07 into these values, so that will be minus 4i minus 5j minus 3k. Over here the values will be 4.68 minus 4i plus 5j plus 0k. Then the last force vector will be 40 by 3. So that is 13.33 into 0, 0, and this will be 3k. So I'll just write 3k over here. Simplifying this further, I'll be getting the resultant value. I have done nothing but opening up of the brackets over here. These values are as it is, 69, 0j and 12k minus 12k. I've written it over here. The remaining values are nothing but opening up of the brackets. Now what I'll do is I'll club all the I terms, j terms and k terms together and write the final answer for. So this is how I have got the final resultant vector for the 4 forces given to me. Now I need to find out, the resultant part is done, I need to find out the moment of all these 4 forces with respect to the origin. So I'll be taking the moment vector. The moment vector is nothing but the cross product of the position vector and the force vector. So I'll write that equation, the moment vector is the moment about origin for force 1 plus moment about origin for force 2, similarly for force 3 and for force 4. This moment vector is obtained by the cross product of the position vector and the force vector F1. The position vector for force F1, that is this force, with respect to origin, I can take the position vector as OD or OB. Take anything, you will get the same answer. So in this case, if I take OD, I'll just write over here as OD. Similarly, position vector for force 2, since the force is passing through the origin, I will get the answer for this as 0, but I'll just write it over here. For force F3, it will be OF cross force vector F3, and for force F4, it will be cross product of the position vector and the force vector F4. So this cross product, I can write it as I know the force vector F1 is this, so I'll write the values over here, 16, 0 and minus 12. Now the position vector of OD, so that will be, it is O to D, so it will be D minus O So I'll get it as 0, 5 and 3. Similarly, the cross product for force F2 will be F2 is these values. So I'll write it over here. IJK values, that is the position vector over here, will be O to G. So it will be 4 minus 0, 5 minus 0 and 3 minus 0. So it will be nothing but 4, 5 and 3. I'll just write this again over here as K and this value as J. Similarly, force cross product for force F3, I can write it as IJK. I have only I term and the J term. This K term is for the fourth force, so I won't be taking this. I'll just write these two. So it will be minus 18.7 and 23.4. K is 0 in that case. Now the position vector for force F3, that is OF, position vector along OF. So I can take, this is F3. So OF will be 4 minus 0, 0 minus 3 and 3 minus 0. So that is nothing but 4, 0 and 3. 4, 0, 3 plus cross product only force vector K term is there, so I'll write it over here 39.9. I and J is 0, whereas for OA I have written OA over here, so I'll be getting it as 4, 0 and 0. So now the simplification of this will be so these values are nothing but the determinant values over here. For I, it will be minus 60 minus 0, that is minus 60 I. Then minus J, this will be 0 and this will be minus 48. So minus J minus 48 and K will be, this term is 0 and 16 into 5 gives me 80. So I'll write it over here. So the next determinant that I'm having, so this is 0 minus J, again this is a 0 term, and K, as I said, for the force F2, since it is passing through the origin, I'll be getting it as 0, and that is what is happening over here on simplification as well. So I'll just do the calculation for K as well. That will be again 0. So this complete term becomes 0 because for the moment vector of force F2 is 0 because force F2 is passing through the moment center, that is origin. So that is coming out as 0. Similarly, I can do for F3 moment. So that will be I. This will be plus because the term over here is coming out as 0, and 0 minus of minus, this will be plus, so that will be plus value over here. Similarly, I can write for k, and that will be so the last moment vector for force F4 will be I 0 minus j 160 plus k will be 0. So what I'll do is I'll just take the summation of all the like values together, that is I terms together, j terms together, and the k terms together, to finally get the moment vector, the net moment vector. So in this case it will be minus 60I plus 70.2I, that's it. J will be plus 48J 0, this will be minus 56.16J, and this will be again minus 160J. K term will be 80K and 93.6K. So this will be 10.2I. This, I'll get the negative value over here. .16J minus 160 I'm having, so I'll have to add this value as well, so it will become 168. So minus 168.16J, and this will be 173.6K. So this is the net moment vector for all the four forces above origin. So this is how we can find the resultant and the moment vector for the given force system. I hope this example was clear to you all. Thank you.